Hey guys, so we are continuing on. Hopefully you guys are doing these with me. So the more we do, the more comfortable you'll feel doing them. So here we are with x squared minus 2x minus 3. So the first thing it tells us to do is to find the x-intercepts. So anytime you find x-intercepts, that means you always set your equation equal to 0. So first thing we notice, hopefully, is that our leading coefficient is positive. So we should end up with a parabola that points up or opens upward. We're going to set this equal to 0. That means we need two numbers. When we factor it, we need two numbers that when we multiply them, we get a -3. Negative products means our two numbers have different signs, and a sum of -2. So we're going to go with -3 and +1. And then since it's equal to 0, we're going to set both of our sets of parentheses equal to 0. We're going to solve for x. And to solve for x, we're going to add 3 and subtract 1, which means our x-intercepts are both -1 and +3. So our x-intercepts are -1, 0, and 3, 0. Okay, so now we're going to find our vertex. So when we have a parabola that opens up, that means the vertex is also our minimum value, the lowest point on our parabola. And to find the vertex, we always use the opposite of b, or -b over 2a. So a is 1. It's always what's multiplied by your variable squared. B is always what's multiplied by your variable to the first power. So our b is -2. So down here, we're going to plug in the opposite of b. So the opposite of -2 is +2 over 2 times a, which is 1. So we have 2 divided by 2, which is 1. So the x value of our vertex is +1. And to get the y value, we plug in 1 for x. So 1 squared, we're going to do 1 squared minus 2 times 1 minus 3. So 1 squared is 1, minus 2 minus 3. So that would be -4. So our y value is -4. All right, now we're going to look for two other coordinates besides our x-intercepts and our vertex. So we're going to sketch a little T-chart right here. Our vertex is going to go in the middle. One of our x-intercepts is up here on the top. The other one's down here. Doesn't matter how you arrange them. But I just like to think, okay, well, what are two numbers that are on the both sides of my vertex? So I'm going to let x equal 0 and x equal 2. And since they're the same distance from the vertex, since parabolas are symmetrical, my y value should be the same. So we're going to do 0 squared minus 2 times 0. So everything's 0 so far. And 0 minus 3 is -3. And then I'm going to plug in 2 for x, 2 squared minus 2 times 2. So that's 4 minus 4 is 0. And 0 minus 3 is -3. So there's our two other points besides the 3 we had. So let's graph these. We're going to do -1, 0, 0, -3, 1, -4, 2, -3, 3, 0. And when we connect our dots, we have our happy parabola. That's what we wanted. And then finally, we want the line of symmetry, so a vertical line, because if we fold this parabola right down the vertex, since it's symmetrical, the two sides will fit on top of each other. So that vertical line always starts with x equals, and it's always the x value of our vertex, and that is a +1.
Anthony Lentini to check out.
Anthony, check out. All right, so that is our line of symmetry. It's always the x value of your vertex. All right, the next one, go ahead and change your original equation. I figured out earlier my original equation didn't work very well, so we changed it to these. I think I changed both of these from minuses to pluses. So please do that and then work these out with me. All right, so to find our x-intercept, that means we want y equal 0. So we're,
Michaela Wilburn to check out.
all right, so we're going to set this whole equation equal to 0. Now, even though, first of all, our leading coefficient this time is a negative, which means our parabola should open down, right? Or it should be a sad face. And now just to factor it, just to make it easy, I do want to make that leading coefficient a positive. So I'm going to factor out a -1, which will change all of my signs. And this is just to factor it. So I'm ignoring this -1 right there for a few minutes. So once again, I want two numbers that multiply to give me -3 and add to give me -2. So I need -3 and +1. So -3 times 1 is -3, and -3 plus 1 is -2. So I know I'm right. So I'm going to set these both equal to 0. And then I'm going to solve for x. To solve for x, I would add 3, and this one I would subtract 1. So my x-intercepts are 3 and -1. So let me erase all this. I had to do all that to get my two solutions, Oh no, did I just forget them? You guys, shoot. Let's see, it was -1 and 3, right? Ooh, -1 and 0 and +3 and 0. Is that right? Whoops, I put it in the wrong place. I think that's right, you guys. Did I mess up? I don't know. All right, well, I'll find out in a few minutes. All right, now we're going to do the vertex, even though I wrote the x-intercepts as the vertex. That's not right. All right, so anyway, we're going to do -b over 2a. So going back to our original equation, a is -1 and b is 2. So the opposite of +2 is -2. And then 2 times a is -1. So -2 divided by -2 is +1. So my vertex, I'll write it up here. My vertex is 1, and then to get my y value, I have to plug in 1. So I'm going to do the opposite of 1 squared plus 2 times 1 plus 3. So 1 squared is 1, but then it says the opposite of that is -1 plus 2 plus 3. So I have 2 plus 3 is 5 minus 1 is 4. All right, so according to what I have here, one of my x-intercepts is 0, 1. The other one's 3, 0. And then 1, 4. Okay, I think that's right. I don't know why I erase things and don't write them down, you guys. It's a terrible habit, terrible habit. All right, so let's write down what we have so far and then come up with 2 other points. All right, so our vertex is 1, 4. Our other points are 0, 1. -1 and 0 and 3, 0. So I want x to be 0 and x to be 2 because they're on both sides of the vertex. So if I plug in 0 squared, I get 0. 2 times 0 is 0, and 0 plus 3 is 3. So don't go right or left, go up 3. And then I bet 2 is also 3. So we have the opposite of 2 squared plus 2 times 2. So that's -4 plus 4 is 0, and 0 plus 3 is 3. So we find out it is in fact symmetrical. It does open down like we expected it to. And the last thing is the line of symmetry. The line of symmetry is going to be this vertical line. Vertical lines always have an x in its equation. And that x value is +1, which is always the x value of the vertex. All right, how are you guys doing? I hope you're doing these with me. All right, once again, I changed the signs, I think, on 2 of these. So please, or maybe only 1 of these. So please change your signs to the way this is written now. All right, so once again, we have a negative coefficient. Once again, we're going to have a sad parabola, frowny face. We're going to find the x-intercepts by setting this whole equation equal to 0. All right, and just to factor it, I'm going to factor out a -1 because it's easier to factor that way, which basically changes all my signs when I pull out a -1. So this time I need two numbers that give me -2 when I multiply, but +1 when I add. So 2 times -1 is -2, and 2 plus -1 is +1. So now I set both of these bad boys equal to 0. When I subtract 2 and add 1, I solve for 0. So I find out my x-intercepts are 1 and -2. So x is 1 when y is 0, and x is -2 when y is 0. Awesome. Goodbye, goodbye, goodbye. All right, let me find the vertex. Hey, you guys, do you know what? Oh, you probably wouldn't even understand that joke. Y'all are too young. Your moms would understand. Your dads would understand. What kind of jeans does Mario wear? What kind of jeans does Mario wear? The answer is denim, denim, denim. Let me know if you got that joke. Let me know. Some of you are like, what does that even mean? Some of you will be, that was cute. All right, anyway, the vertex is -b/2a. So our a is -1. I know some of you OCD people, that little mark right there is driving you crazy. So I'm just going to get rid of it. All right, b is also -1. All right, so what's the opposite of b? The opposite of -1 is +1. And 2 times a is -1/2. Oh, I don't like that, but we're going with it. All right, so our x value is -1/2. So we're going to plug that in and find the y value. So we're going to plug in the opposite of x squared. So x is -1 squared minus -1/2 plus 2. So I know -1/2 times -1/2 is +1/4. And the opposite of +1/4 is -1/4. And I know this is a bam bam. All right, so +1/2 plus 2. So I'm going to plug that right in my calculator. I'm going to say the opposite of, -1/4 plus 1/2 plus 2 is 2.25. And I'm writing that as a decimal because that's easier to graph than, I don't know. I mean, we know our quarters, don't we? But anyway.
Colin, back from the checkout.
Everybody's checking out, you guys. So that's one thing you don't miss, I'm sure, is announcements on the intercom, having to check out when you're ready to go home. All right, so now let's think about our 2 other points. So we're going to start with our vertex in the middle. So we're going to do -1/2, +2.25. And then this time I'm going to use whole numbers, all right? Excuse me, let me wait just a second. Let's see. I've decided this time I'm going to use a number on the other side of 1, which is going to be a 0. And now I'm going to use -1. Yeah. So anyway, you don't always have to find a number right between the numbers you already have, but you want to stay really close, guys. You want to stay really close to that, what's it called? Vertex. I don't know what my mind is doing. You want to stay really close to the vertex, all right? So I'm going to use 0. So -0 squared is 0, minus 0 is 0, and 0 plus 2 is 2. And then I'm going to use the opposite of -1 squared minus -1 plus 2. So -1 squared is 1. The opposite of 1 is -1. And then I do bam, bam, plus 1. So -1 plus 1 is 0, and 0 plus 2 is 2. Okie dokie. So I'm going to graph 0, 2, 1, 0. Oh, go away. And then -1/2 up 2 1/4, just barely right there. And then -1, 2 right there. And then -2, 0. All right, so this opens downward just like we knew it would. And finally, my line of symmetry is x equals that x value of -1/2, the x value of my vertex. All right. All right, let's move on. All right, now this one, if you notice, this has it's a third degree polynomial, right? Our leading coefficient is a +1. So we're not going to figure out exactly what this graph is going to look like because it would actually take us calculus to do that. However, we can figure out approximately what it will look like. So there's a few things we can be sure about. The first thing is, since the leading coefficient is a positive number, our graph will begin and end with a positive slope. So remember, positive slopes go up and to the right. So our graph will begin going up and to the right, and it will end going up and to the right. Now, cubic functions always go up, or they start going, at the beginning, they go down. They always go up, and then they do this little, oh my goodness, that was terrible. They do a little switcheroo. What am I can't do it now. Yeah, so they will start, they'll start going in a positive slope and end in a positive slope, and they always have this little loop in the middle. Or the opposite is true. They'll start with a negative slope, turn around, and end with a negative slope. Okay, I know these are horrible. So this is a little better. This one's okay. So sorry about that, but watch the Florida virtual link, and it does a lot better job than I just did. However, let's talk about what we can be sure of. So what we can be sure of is our x-intercepts and our y-intercept. Okay, so remember, on all the quadratics, we ended up with 2 solutions, 2 x-intercepts. Since this is a cubic function, we should end up with 3 x-intercepts. So first thing we're going to do is factor this guy. And since there's 4 terms, we're going to factor by grouping. So what did they have in common? These first 2 terms, we can factor out an x squared. So x to the 3rd divided by x squared is x minus 1. And then we're going to pull out a -16, and we get x minus 1, which is what we were wanting. We wanted these to match. They do. So one of my factors is x plus 1, or excuse me, x minus 1. And then the other, we're going to put these 2 outside terms together. All right, but we were supposed to end up with 3 terms, right? Or 3 solutions. Well, if you notice, this one is the difference of 2 squares. So we're going to find the square root of x squared, find the square root of 16, and then one gets a plus and one gets a minus. And then our third term, or third factor, is x minus 1. So then we're going to set all these equal to 0. So we're going to do x plus 4 equals 0, x minus 4 equals 0, and x minus 1 equals 0. So then when we solve for x, we're going to subtract 4. Oops, we would add 4, not 5, 4, and add 1. So our x-intercepts are -4, 1, and +4. So our x-intercepts are -4, 0, 1, 0, and 4, 0. All right, -1, 2, 3, 4, 0, 1, 0, 2, 3, 4, 0. All right, so that we're sure of. And then the other thing we can know for sure is, besides our graph beginning and ending with a positive slope, so going up and to the right, the other thing we can be sure of is our y-intercept. Now remember how we find y-intercepts? We have to set blank equal to 0. We have to set x equal to 0. So we're going to do 0 cubed, which is 0, minus 0 squared, which is 0, minus 16 times 0, which is 0, and 0 plus 16 is 16. So our y-intercept is 0, 16. Now, obviously, my graph's not numbered up to 16, so just so we can kind of just estimate the picture, we're going to pretend that our y-axis is counting by 2. So 2, 4, 6, 8, 10, 12, 14, 16. So we're going to pretend that's 0, 16, even though the x-intercept or the x-axis I counted by 1. It's no big deal. All right, so I'm so bad about drawing pretty straight lines. I do know our graph goes up and to the right when it begins and when it ends. It would go way up here somewhere. See, I'm already messing up. It would go way up here somewhere, and then it's going to take a loop, and it's going to cross the y-axis at 0, 16. It's going to come on down. It's going to cross the x-axis at 1, 0, and then it's going to do another loop, and it's going to end going up and to the right like it began. Okay, that's an estimation. We know a few things for sure. You're not going to be asked to graph one of these until you're in calculus, which you will be in a couple of years. But then I saw the actual graph of it. Looks like this. So not too shabby, right? We're not exact, but we didn't get it off too badly. And so we can just, at this point in math, we're going to just estimate what cubic functions would look like, but we don't have to estimate quadratic functions. You guys know how to graph those. All right, so this is going to be your assignment for Friday, April 15th. I know you guys love my jokes. They're so funny. So you're going to follow these directions right here. You're going to solve by factoring, then find your answer, your solution in the answer column. Each time the exercise number appears in the code, write the number of the solution in the space provided. If the answer has a darked out circle, leave the space blank. So first thing we're going to do is number 1, we're factoring. So we are thinking of two numbers. When we multiply, we get 12. And when we add, we get positive 7. So that would be what? 3 and 4. And since this is a quadratic function and we're setting them equal to 0, when we solve for when we solve for x, we're going to subtract 4, subtract 4, subtract 3, subtract 3. So our two solutions are -4 and -3. So our number 1, our two solutions are -4 and -3. So if you find that in the top box at the middle part of the paper, that's letter C. Letter C. Okay. All right, let's do number 9. All right, number 9. So since our leading coefficient is not a 1, we're going to use the, what's it called, AC method. So let's multiply 5 times -18, and I get -144. So -144, so number 9, we get -144, but we want a sum of 9. So I know 12 and 12 is 144. What else can we divide one? How about 16? Will that work? 16 and 9? Nope, that doesn't work. How about 18? That doesn't work. How about 13? No. How about, I don't know, 22? Nope. How about 23? How about 19? How about 21? How about 17? Oh my goodness. How about 14? How about 13? Well, no, it's not 12. 9 and 16. Well, that doesn't work either. How about 8? I already tried 8. How about 7? No. How about, why can't I figure this out, you guys? What's going to give me anyway, I can't figure it out. What's wrong with my brain? I don't know why I can't figure this out. 11? Nope. 15? That can't be 15. 10? No. Anyway, oh my gosh, I'm wasting all my time. All right, I don't know why. I'll send y'all the answer to number 9. I don't know what's wrong with my brain. Did I multiply 5 and 18 right? No, it's 90. Why did I put it was 144? You guys, I've lost my brain. That's why I couldn't figure it out. What in the world? 5 times 18 is 90. I don't know what I multiplied by. Oh my goodness. All right, so sorry. So we need 2 numbers that multiply to give us negative 90, but add to give us 9. So that would be what? It can't be 9 and 10. Would it be 5? 5 and 18? No, it would be, oh my goodness. Are y'all like, is she really doing this again? 90 is 90 and 8. No, 90 and 6. 90 and 6 is 15. So 15 minus 6 is 9. All right, so we're going to do 5t squared plus 15t minus 6t minus 18. Sorry, that took way too long. All right, anyway, let's factor these first 2 terms. We get 5t, and what would be left out of 5t squared would be t plus 3, and then we're going to factor out a negative 6, and then we'd have positive 6 plus 3, and we get 0. Okay, so this is number 9. So one of our factors is t plus 3, and we're going to set it equal to 0. And the other factor is 5t minus 6 equals 0. So we're going to do the opposite of plus 3. We're going to subtract 3. So one of our solutions is negative 3 for number 9. And the other one, to solve for t, we would add 6 to both sides. We'd have 5t equals 6. And then we'd divide by 5. That means the other solution is 6 over 5. 6 over 5. So I'm looking for our 2 answers. And this is, oh, it's on the bottom. So 6 over 5 and negative 3 is t, letter T. So number 9 is letter T. Okay, I just wanted to solve one like this for you guys so you would know that sometimes we do get fractions, okay? All right, so anyway, the very last problem, was that not, I thought we had one more. Nope, I guess that was it. All right, well, gosh, sorry I took so long on that last problem, but anyway, so hopefully you guys can do that on Friday the 15th. And if you need some help, let me know. I've already set up our, actually Friday is not the 15th. It must be for 16th, the 16th, which is Friday. And I've set up a Zoom meeting for us for Friday the 16th at 10 o'clock. So you guys come on. I know this has been a tough week. And you need to let me know if you need some help. Join the Zoom meeting, send me a message, whatever you need to do. All right, guys, have a good day. I'll see you guys later.